Hey, I'm just going to go through the review that you got today in class for the test that's tomorrow on Friday. Uh, so you've got the review. Sorry I wasn't there in class today, but I am going to go through these questions here on the review so that if you had questions, maybe they'll be answered. So very first one here is a pattern, a visual pattern of people arriving to a party. So first thing, what's going to be an expression to represent the number of people at any nth minute? This is, first of all, a sequence. So what I'm going to do is I'm going to say, okay, there are 3 people here, and here there are 5 people, and here there are 7 people, which means that each time each time 2 people being added to how many people are there. So we have a pattern. It's +2 for each minute that passes. Now, this is the first minute, the second minute, the third minute. So before people started arriving, there was a single person there. This means that we're starting with 1 person and adding 2 people on for each minute after that. Now, if you want to know after 6 minutes, you just continue the pattern and say, okay, first person plus 2 people for over 6 minutes, that's going to be 12 plus 1, 13. Now, at what time will you have 121 guests? So we're asking you what minute, so I'm asked, the question is, at what minute will you have that many people? This is solving just an equation. There's the equation. Okay, subtract a 1, subtract a 1. Now you have 2n equals 120. And divide away the 2. And after 60 minutes, she'll have 121 people at her party. Okay, direct variation. Y varies directly with x. So you know that the equation looks like this. You can also use a proportion to set this up. Now, here you're being asked for the constant of variation. Now, just to also say it like this, the constant of variation is the same thing as the slope. So if you're used to m, use m, but k is the variable that we usually use for that with direct variation. So basically, we've got a y value and an x value, and what we're going to do is take our equation and determine the slope or the constant. I'm going to replace the y value, and I'm going to replace the x value. Now to find out what the constant is, all I've got to do is divide this. I'll reduce that. Those can both be reduced by a 2 or divided by 2. So there's my constant of variation. What is the slope of the line that passes through these 2 points? Okay, the way that we looked at this in class, now again, rise over run, that's going to be y values over x values. Now, how we looked at this in class was we approached it as how far do I have to move to go from the first point, the 1 here, to get to the second point, the 5 here. And again, I'm looking at the y values because that's my rise. So how far do I have to move to go from 1 to 5? That's a pretty simple question, and a lot of people are fine with that. And you would say, I just have to add 4. That's all that's got to happen. So then that tells me that my rise is 4. Okay, do the same thing from 16. How far do you have to move to go to 4? And again, I'm looking at, those are my x values. Okay, well 16 I'm going to have to subtract, and that would be, think it out, minus 12. Okay, so that would be my slope, 4 over 12, which you could reduce down to 1/3. Now, if you don't like guessing the numbers here, take these first 2 numbers, subtract the second 2 numbers, So that would be a -4, and that would be a 12, and that would still reduce down to -1/3. There you go. Okay. So for the given equation, graph the line and provide this information. So first things first, I'm going to take this, and there are a couple of approaches here that you can take. First, you can just get the x and the y-intercept, and that might be the easiest thing. So for instance, for the x-intercept here, I can just go in and say, all right, y value has to be 0, so if I put in a 0 for my y value, then all I'll have left is the 6x and the 12. That's it. Y's gone because of the 0. Solve it out. Okay, my x value has to be a 2. There we go. Same thing for the y-intercept. Yeah, it's a y-intercept. My x value has to be 0. So if I take the same equation and I put in a 0 for x, well, the x goes away, and now all I've got to deal with is the y. And again, just finishing and solving that. Sorry, I keep writing 2's for that. So finishing and dividing, that would be a -4. So there's my x and my y-intercept. All right, and that was pretty straightforward. I just put a 0 in for one variable, solve for the other. There's my x value. Put a 0 in for the other, solve for the other. And there's my y value. Now I can take this information and I can go over here and I can plot 2 on the x-axis and -4 on the y-axis, and I can draw a line connecting those points. So there's my graphing part. Now the slope, though, that's something else that I don't know. I can figure that out real quick, though. I can count up 4 units and I can count over 2 units. So there's my rise and my run. That would be 4 over 2, which means my slope is just going to be 2. Now you could also have started with solving for y, and once you solve for y, then you'll have the slope-intercept form. So that would be the slope, and that would be that part of your information. And then this number here at the end would be your y-intercept, and that would be this piece of your information. And you would just read the graph after graphing it to get the x-intercept after that. Okay, continuing. So this is the second page. So reading through this problem here, what I'm going to do is I'm going to jump straight to the question. So what is Cameron's rate of change? Now, when we're saying that, what we're asking for, what we're meaning is the slope. So what's the slope in this situation? Well, from 144 miles, we ran out and down to 0. Sorry, no, I'm thinking about that backwards. If we start with 0 miles and travel 144 miles, and we start with 6 gallons of gas, and at the end of that we're out, then what we have is that minus 6 gallons plus 144. So my rate of change, so from 0 to 144, that's how many miles were driven. I lost 6 gallons over that period of time. So dividing that, I'm going to have a negative 24. There's my slope. And again, I just looked at my numbers here, and you could have used 144 and 288 and gone from 144 to 288, or switch the order of the numbers in any way, and you would still end up with this same negative 24 as your slope. Number 6, use the graph below to answer the following questions. So this is our whole transformation thing. Now what's going on here is that's a vertical transformation. That's going to be because that 2 is not inside of here affecting the x. Now because it's on the outside there, we're going to be able to do a vertical, and because I'm multiplying with a larger number, I'm going to be doing what's called a stretch. So if this is the original graph, and I'm just going to put 2 marker points on here, I'm going to be stretching and pulling the graph further apart. Now to give you actual values, okay, x, y, I'm going to use just those 2 points, -2, -2, 2, 2. And what I'm going to do is, now because this is vertical, that's going to be affecting my y values, I'm only going to change the y values. X, y, -2, 2. So I'm only going to multiply with 2 for these y values here. So 2 times -2, there's a -4. 2 times +2, that's going to be a +4. All right, -2, -4, +2, +4. So what's happened is, if you compare with these original points, and I'm going to change color and graph this so you can see the difference here. Here's the new line. So again, if I stretched these points out and pulled the graph apart, then I'd have the new stretched out line. All right, very last one. So transformation, here it is. It's all on the insides. This is all horizontal stuff. Okay. So this is all going to be left and right. Now that -2, that's going to be changing to a +2, which means that I'm shifting to the right. So I'm looking for, there they are, not using left. So those are out. Now it's either flipping over the x or the y axis. So if I have a graph, and I'm going to try to be as detailed with this as I can, if I have a graph and I want to do a horizontal, that is left and right, reflection, then that's what this negative here is doing, so we talked about in class. Then what I'm going to be doing is reflecting my graph like so. Now whenever I just did that reflection, I reflected that line over the y-axis. I went left and right, reflected to the left, reflected to the right. That's what made my reflection. So I'm flipping my graph over the y-axis there. Okay. I know that reflection, we didn't really get to have a whole lot of time in class to talk about that. So there's another look at it. Maybe you'll be a little more comfortable on a test with it. Okay. There you go, guys. Hope that's able to help you.